I'm like, I really think bro, yeah. Ocean helped us with it. All right, let me go over the quiz details for tomorrow, and today we're just going to review. So tomorrow, I have a morning review at 7:30 a.m. I will spend that time tomorrow to go over this quiz review worksheet that you just picked up. This is not what we're going to work on today in class. We're going to work on the review that's in your packet. Okay. This I'm hoping that you guys either go home and do on your own as your own review practice. The key is attached, or you can wait for me to go over with you tomorrow morning. Okay. Tomorrow quiz, you'll be given the blank unit circle, or blank unit circle will be on the quiz, and you can use that. So that's why we're spending these days, reviewing and kind of thing, and making sure you're really comfortable with unit circle. The unit circle fact sheet that you just picked up, I have blank unit circles on both pages, so maybe you can do one in class today, and then you can do one either tomorrow morning or later today as additional practice. I will provide you the pink formula identity sheet that you used on the previous test. Okay, so that'll be provided for you. And no calculator tomorrow. Okay. Any questions about the quiz at this time?
Can I go get my packet? I accidentally put my previous class.
Yes. Or I have an extra one. Okay, no questions? Okay. It'll be front and back, the length of this quiz review worksheet here. Yeah, so. All right, so let's look at. Okay, page 5 in your packet.
Oh my God. Bus.
Okay, so first thing we do here is recognize that the 105 is not the angle that we recognize on the unit circle, but if we can play with unit circle values and try to think of two numbers that can either add or subtract to 105 using the variations of 30, 45, or 60, or multiples of 45, 30, 45, or 60. Either we can think of two numbers that add or subtract. Maybe adding was a little bit easier to do. So any ideas there? Okay, 45 and 60. Okay, so we can do that. So we can use our sum and difference identity, right? So this falls in that category of sine of A plus B. Right. Pull this from your formula sheet, but I can also put this one up so you can. And this time you probably want to go ahead and practice or start filling in that first quadrant of your unit circle. That's the most important quadrant, right? If you get that quadrant 1 down, then everything else is going to come from that. So go ahead and practice filling in that first quadrant on your unit circle.
Root 2 and root 6 do not combine. Those are not like terms, so best we can do is just put them next to each other, but can't make that root 8. It's not the same thing. Any questions with number 1? Number 2, tangent of 17 pi over 12. Maybe we don't recognize that, that angle, but we can try to think of 2 fractions that can add up to be 17 over 12. And so we just have to play with different numbers and see, can we think of 2 numbers that, 2 fractions that will eventually reduce to unit circle radian measures. Okay, so try that first. And, you know, sometimes there's more than one variation, which is fine, but ultimately we're going to be able to get down to the same answer. What do you guys find? Any ones that work? Yes, you're pulling them from unit circle, but initially they may not feel recognizable because they may not be reduced fully. So you kind of have to play with different numbers and see if those fractions actually come out to be unit circle values. So it does take a little bit of trial and error, right? We're not going to get it first time, but hopefully after a couple of tries, we can find 2 numbers that work. Anyone find any numbers that work? 11 and 6. 11 and 6, yeah, that works. I did 3 and 14, but yeah, 11 and 6 works. I can do that. Then 5 or 12. Well, let's see. Let's see. 11 over 12. That's not unit circle, right? Pi over 2 is 11 pi over 12. I mean, we have 11 pi over 6, right? But 11 pi over 12, I don't know if that quite works. Okay, what's another guess? 8 and 9. Okay, I think that works. So tangent of A plus B. Tangent of A plus tangent B all over 1 minus tangent A tangent B. Okay, what's tangent to 2 pi over 3? Family of pi over 3. They're going to be positive or negative. Second quadrant, right? Negative or 3? Tangent of 3 pi over 4, that's also in the second quadrant. We know tangent is negative. If you rationalize the denominator, you would get root 3 plus 2. Either is fine. Okay, so if you think about your unit circle value, right, 2 pi over 3. We know that tangent is sine over cosine. So sine over cosine, I can just cover up the denominator because those are just going to go away. So I get negative root 3 over 1. Right, so the way you would rationalize the denominator is you would multiply by the conjugate. Multiply by the conjugate. So I can show that works there. So it'd be negative root 3 minus 3 minus 1 minus root 3. And 1 minus root 3 times 1 plus root 3 will be 1 minus 3, which is negative 2. Split into individual fractions. Okay, number 3, that makes sense. Okay, so number 3 made it a little bit easier, but I know if you were to do such a large number, what would you do to make it more recognizable? Yeah, keep subtracting what? 360, right? So, but I'll make it easier where you can find. So let's do 285 instead. 285 is not a unit circle value, but maybe we can think of two numbers that can add up to be 285 that happen to be unit circle values. 40 and 45.
What values you do, like, should you? Doesn't matter what values you use, like, should you always end up at the same answer?
Yes, yeah, so if you use any unit circle value, that either add or subtract to 285, our steps may look a little different, but in the end, we should match. Like, no. Okay, so cosine of 240, that's a variation of 60-degree angle in the third quadrant, so we know that's going to be negative. Like subtracting straight. And yeah, I mean, you can if the roots match. So if it was like 4√6 minus 2√6, then we can subtract it, we can make it 2. This is really 1√6 minus 1√2, they're not matching, we can't convert them. Okay, number 3, sorry, number 4, this is where we, draw our triangle. So it says that sine is 12 over 13, cosine is negative. From those two information alone, can we narrow down which quadrant we must be in? Okay. Into your ASTC to kind of help you eliminate and corruption. So that means we want sine positive and cosine negative. Second quadrant, right? Okay, so it's important that you know which quadrant that you're in. Otherwise, choose the wrong quadrant. Your very values may be correct, but your signs will be off. Okay? So you want to make sure through today's review and the review that you're going to do either later today or tomorrow that you picked up, that you are very comfortable making sure that you're landing in the right quadrant based off the information that they give you. Okay. Any questions with that? Okay. Okay, so now back to sine of theta equals 12 over 13. We can assign the appropriate side, opposite over hypotenuse, Pythagorean theorem. So, with the Pythagorean theorem, I get 5, after I've subtracted everything, but we gotta be careful, right? Because when you look at the Pythagorean theorem, they're always gonna give you back a positive number. You always have to make a decision, do you wanna keep that positive number, or do you need to make some adjustments? So in this case, is this gonna be a positive 5, or should it be something else? Negative, right? Second quadrant, I gotta go left 5 and up 12. This is the hardest part, right? Trying to get that triangle to be in the correct quadrant, and also making sure that you're assigning the correct positive or negative, once you're in that triangle. Now, you're just getting that tangent to theta out of double angle, and then replacing, with ratios. Before. Oh, you're talking about this 5 right here?
Yeah, that one.
So, I want to make sure that we understand something here. As long as there's one negative, they all mean the same. You can put them anywhere you want. They can always put them, you can put them anywhere you want, and still they all mean the same. Okay, number 5. First things first, right? We got to make sure we can land in the correct quadrant here. Tangent is negative, secant is positive. Now, what's secant related to? Cosine, right? So let's just think in terms of cosine then. So tangent negative, cosine positive. Positive. Okay. So that's an important first step, right? We need to be able to use those two pieces of information to narrow down our quadrant and be able to go there. Any questions about that? I'm going to ask so that I can help clarify that. Fourth quadrant? Make sure your triangle are drawn in this way where you're never going to draw a triangle with the y-axis, right? So if you draw it this way, this is wrong. You want to draw it this way. Gotta make sure that your triangle touches or shares a side with the x-axis. Right, we don't want to draw it this way. Opposite over basis. So the y value is going to be negative because you're talking about fourth quadrant, but the x value is going to be positive. Okay, Pythagorean theorem will get you to your hypotenuse. And you can expand cosine 2 theta. Now there's three variations of cosine 2 theta. It doesn't matter which one we choose. We have every information that we need, right? We can find sine squared theta, we can find cosine squared theta, or either variation. Okay, a squared plus b squared equals c squared. Find your c value. I chose to use 2 cosine squared minus 1, but choose yours and we should still match. Your hypotenuse is always positive. Cosine of theta is 8 over root 89. Put that in parentheses, square it, common denominator, and then work my way down to my fraction. Okay, page 2. Okay, so here we have to involve sum and difference identities because we have 2 different angles. Okay, so let's look at those 2 angles here. X is between pi over 2 and pi, so what's x equals? Or which quadrant is that in? Quadrant 2. And then y is between 3 pi over 2 and 2 pi. Quadrant. Okay, so let's draw 2 triangles. One triangle for angle x in the second quadrant. One triangle for angle y in the fourth quadrant. I'll put this in the space in between the problem and A and B, so I can have that space to do that. Okay, so for x, we have some information here. Sine of x equals 15 over 17, so opposite over hypotenuse. Cosine is 4 over 5. Pythagorean theorem to find the third missing side, and then we can start breaking them down after we expand, using, sum and difference identities. Hey, I got a positive 8, but here on the triangle, I'm gonna put a what? Is it also positive 8 here? I'm going left, so that should be what? Negative 8. Okay, 3, 4, 5 triangle here, but I'm dealing with a y value in the fourth quadrant, so that should be a negative 3. Try part A, cosine of x plus y. I'll give you the, identity, okay, any questions with C or E? Okay, try E and F. For E, it says what quadrant is X plus Y in? You're gonna rely on what you gather from A and C to help you conclude which quadrant you're in. And then for Y minus X, you can use B and D to help you conclude which at the time. So, let's try and we'll talk about it. Okay, so, for A, we see cosine of X plus Y is a positive, so positive cosine. Tangent of X plus Y is also positive. So ASTC, which is the only quadrant with both cosine and tangent being positive. Quadrant one, yeah. Which quadrant is y minus x in? Let's see, sine is negative and cosine is negative. So which quadrant is both sine and cosine negative? Quadrant three, yep. Okay, for G, H, and I, you're going to expand those double angle identities, but you're just going to rely on triangle X. Go ahead and find sine X and cosine X from your first triangle. Make those substitutions and reduce your fraction. For cosine of 2x, doesn't matter which tangent we use. Any of them will work, right? Cosine squared minus sine squared, we have enough information. You can do the cosine squared x minus 1, that'll work as well. You can do the 1 minus sine squared x. Get all that information from your first triangle. So it says which quadrant is 2x in? Let's see, sine is negative, cosine is negative, tangent is positive. Which quadrant must that be? Sine negative, cosine negative, tangent positive, quadrant what? Everything else is negative, right? It'll be front and back like this, refer response like this. I really encourage you guys to go through the other worksheet that I gave you. That'll be a great review for your quiz tomorrow. Either work it tonight or you can come tomorrow morning and do the help session with me at 7:30. Okay. No calculators. I will give you the formula sheet with all the identities, like the pink sheet on the quiz from the test. And then make sure you practice your unit circle. I'll give you a blank unit circle. Okay, I'll get your phone.